The F-16 is a single-engine, highly maneuverable, supersonic, multi-role tactical fighter aircraft. It is much smaller and lighter than its predecessors, but uses advanced aerodynamics and avionics, including the first use of a relaxed static stability fly-by-wire flight control system to achieve enhanced maneuver performance. Highly agile, the F-16 was the first fighter aircraft purpose-built to pull 9-gram maneuvers and can reach a maximum speed of over Mach 2. Innovations include a frameless bubble canopy for better visibility, a side-mounted control stick, and a reclined seat to reduce G-force effects on the pilot. It is armed with an internal M61 Vulcan cannon in the left wing root and has multiple locations for mounting various missiles, bombs, and pods. It has a thrust-to-weight ratio greater than 1, providing power to climb and vertical acceleration. It is designed to be relatively inexpensive to build and simpler to maintain than earlier generation fighters. The airframe is built with about 80% aviation-grade aluminum alloys, 8% steel, 3% composites, and 1.5% titanium. The leading-edge flaps, stabilators, and ventral fins make use of bonded aluminum honeycomb structures and graphite epoxy lamination coatings. The number of lubrication points, fuel line connections, and replaceable modules are significantly lower than preceding fighters. 80% of the access panels can be accessed without stands. The air intake was placed, so it was rearward of the nose, but forward enough to minimize airflow losses and reduce aerodynamic drag. Although the LWF program called for a structural life of 4,000 flight hours, capable of achieving 7.33 grams with 80% internal fuel, GD's engineers decided to design the F-16's airframe life for 8,000 hours, and for 9-gram maneuvers on full internal fuel. This proved advantageous when the aircraft's mission changed from solely air-to-air combat to multi-role operations. Changes in operational use and additional systems have increased weight, necessitating multiple structural strengthening programs. The F-16 has a crop delta wing incorporating wing fuselage blending and for-body vortex control strakes, a fixed geometry, undersling air intake, with splitter plate to the single turbofan jet engine, a conventional triplane empennage arrangement with all moving horizontal stabilator tailplanes, a pair of ventral fins beneath the fuselage aft of the wing's trailing edge, and a tricycle landing gear configuration with the after-tracting steerable nose gear deploying a short distance behind the inlet lip. There is a boom-style aerial refueling receptacle located behind the single-piece bubble canopy of the cockpit. Split-flap speed brakes are located at the aft end of the wing body fairing, and a tailhook is mounted underneath the fuselage. A fairing beneath the rudder often houses ECM equipment or a drag chute. Later F-16 models feature a long dorsal fairing along the fuselage's spine, housing additional equipment or fuel. Aerodynamic studies in the 1960s demonstrated that the vortex lift phenomenon could be harnessed by highly swept wing configurations to reach higher angles of attack, using leading-edge vortex flow off the slender lifting surface. As the F-16 was being optimized for high combat agility, GD's designers chose a slender crop delta wing with a leading-edge sweep of 40 degrees and a straight trailing edge. To improve maneuverability, a variable camera wing with a Naka 64A204 airfoil was selected. The camera is adjusted by leading edge and trailing edge flappings linked to a digital flight control system regulating the flight envelope. The F-16 has a moderate wing loading, reduced by fuselage lift. The vortex lift effect is increased by leading edge extensions, known as strakes. Strakes act as additional short-span, triangular wings running from the wing root to a point further forward on the fuselage. Blended into the fuselage, and along the wing root, the strake generates a high-speed vortex that remains attached to the top of the wing as the angle of attack increases, generating additional lift and allowing greater angles of attack without stalling. Strakes allow a smaller, lower aspect ratio wing, which increases roll rates and directional stability while decreasing weight. Deeper wing roots also increase structural strength and internal fuel volume. The F-16 had been scheduled to remain in service with the U.S. Air Force until 2025. Its replacement was planned to be the F-35A variant of the Lockheed Martin F-35 Lightning II, which is expected to gradually begin replacing several multi-role aircraft among the program's member nations. However, due to delays in the F-35 program, all USA F-16s will receive service life extension upgrades.